The adventure of fixing the 30 watts TDP KFA2 GT 1030 started at the main auction site that I visit daily. The ad mentioned the card as not working and being pulled from a PC that would not work either. For just shy of 20 USD including shipping, the offer looked appealing, so I bought the card with the intent of trying to repair it. There are quite a good number of things that I could notice when examining the video card. Scratches scattered all over the back of the PCB, from the I/O shield area all the way to the end of the board, and from the PCIe fingers to the labeled test points. Ugh. Traces of flux and what looked to be resolder capacitors on what I assumed to be a voltage regulator made me even more worried. But nothing topped the backside of one of the two memory chips. There I noticed a batch of 4 capacitors, all missing compared to the other chip. This could make the behavior of the card quite unstable if the voltage regulators were not up to snuff. I followed the same routine as with the R7770-PMD1GD5 and as advised by a Learn Electronics Repair. Great channel, by the way, link in the description. Check resistances, check voltages, check various enable or chip select signals, and see where things go from there. I measured the resistances first, on the 3.3 volts and 12 volts on the PCIe fingers, and found no shorts. I then started measuring resistances between the inductors and ground, and again I found no shorts. Next step was measuring voltages. The KFA2 board I got had really nice placed test points that can be accessed from either side of the board, and they are labeled. This made this step much easier, and when powering up the card, I found that the only voltage that misbehaved was the PCIe V. 5 volts measured 5 volts, GPU V showed about 0.9 volts, DDR-V showed 1.5 volt, and the 1.8 volt line showed 1.8. The card was mildly warming up, so it appeared that it was down just one rail. I looked for all the chips on the board and searched for their datasheets, or at least some partial diagrams. The goal here is to be able to find their outputs and enable signals and trace them to see which one is responsible for PCIe V. It appeared that one regulator was directly connected to the PCIe V test point. One of the images I used as partial schematics showed it connected also to GPU V, and another continuity test confirmed that. The list of suspects narrowed down to the resistors that take the GPU V as a form of feedback. A bad value here can provide a bad voltage level for feedback that would cause the output voltage to drop to 0. The input voltage, the output PCIe V is actually the input voltage as it gets stepped down by the chip. No input voltage means no output voltage, as simple as that. Or maybe the enable signal. If not active, the chip would be basically disabled. The resistor values measured from the feedback pin did not measure quite as expected on the partial diagram I used, but they did not appear to be resoldered either, so it seemed unlikely for them to be the issue. That left only the input voltage and the enable signal. Before powering up the card again, I wanted to check for alternative ways to measure these voltages. The distance between the pins of the IC is small, and one can easily short them. I found the input voltage being provided by a 1117, another linear regulator labeled as U504. This one was fed from the PCIe 12 volt, and the output would be easier to probe than the pin of the IC. Things turned interesting when trying to trace the enable signal. Visually, the trace would move around the edge of the card, connecting pin 2, where the UP0104 regulator has the input for the enable signal, to a resistor on the top side of the board. Problem is, there was no continuity, and one of the scratches that I noticed initially was crossing two traces, one of them being the one that carried the enable signal. So measuring continuity before the scratch and after the scratch made clear that the trace was severed, and this was likely the cause why the car would not start. Soldering iron out, a bit of rosin, a bit of solder and a thin copper wire, and the trace was restored. I measured continuity between the enable pin of the regulator and the intended resistor trace pad. I also measured for shorts between the enable trace and the neighboring one in case my soldering skill would connect the two, and fortunately I found no shorts. The second trace that was also crossed by the scratch had no continuity issue. I again searched for shorts on the various PCA voltages and ground and regulator outputs and ground and found none. I decided to power up the card and it became noticeably warmer, slowly raising up to 40°C and higher. Before things became uncomfortable though, the card put out an image on the monitor and I could happily power down the PC. I repasted the card and reassembled it, then booted the PC. One DDU and the driver installed later, and the card was detected properly. Heaven ran fine. The card was working. I don't know the history of this card. Maybe it went through a repair attempt and the resoldered capacitors were an attempt to fix the no output of the UP0104 chip. And maybe it was then used as a donor board, explaining the desoldered capacitors from the memory chip. I don't know. Fortunately, despite the abuse it went through, the card is now working, without it having to see the inside of my kitchen oven.